Hello and welcome back. I'm glad you found your way here again tonight. There's nothing you need to do right now except settle in and let your body grow heavy against the bed. Let your breathing slow. Let your thoughts loosen their grip on the day, the way a hand slowly opens. Tonight, we're traveling back further than any of our journeys before, long before pyramids or ships or even the first quiet footsteps of humankind, into an ancient world of ferns, volcanoes, and enormous, patient creatures who ruled the earth for longer than we can easily imagine. Some of what you hear tonight may surprise you. Some of it may simply settle over you like warm, prehistoric air, familiar and strange all at once. If any of this helps you unwind, consider subscribing to Drowsy with Facts so you can drift off with us again soon. For now, let's begin. Dinosaurs first appeared on Earth roughly 230 million years ago, and they went on to dominate life on land for well over 160 million years, an almost impossible stretch of time when you consider that humans in any recognizable form have existed for only a tiny fraction of that. To put that scale into perspective, the time separating the very last dinosaurs from the very first is actually longer than the time separating those last dinosaurs from you. Right now, resting quietly in your bed, the gap between the earliest and latest dinosaurs is simply too vast for most of us to comfortably hold in mind at once. Not every dinosaur lived at the same time, or knew any of the others personally, so to speak. The Stegosaurus and the Tyrannosaurus, both familiar names today, were separated by a stretch of time longer than the gap between the Tyrannosaurus and you, an easy detail to forget when they're so often pictured together. The word dinosaur itself was coined by an English scientist in the middle of the 19th century, combining two ancient Greek words to mean, roughly, terrible lizard, though the name is something of a misnomer, since dinosaurs weren't true lizards at all. The very first dinosaur fossils to be scientifically studied and named puzzled early researchers considerably, since nothing quite like them had ever been properly documented before, and scientists had to piece together an entirely new category of ancient creature almost from scratch. Contrary to a common assumption, not all large prehistoric creatures were dinosaurs at all. Flying reptiles soaring through prehistoric skies and enormous marine reptiles swimming through ancient seas belong to entirely separate evolutionary branches, related to dinosaurs but distinct from them. The largest dinosaurs, enormous, long-necked plant eaters, could grow longer than several city buses parked end to end, their sheer scale so extreme that scientists still debate exactly how their hearts managed to pump blood all the way up such an impossibly long neck. Despite their massive size, many of these long-necked giants are believed to have had surprisingly small brains relative to their body size, though this doesn't necessarily mean they were unintelligent, simply that a smaller brain was sufficient for the kind of steady, methodical, plant-eating life they lived. The Tyrannosaurus rex, perhaps the most famous dinosaur of all, had a bite force strong enough to crush bone easily, among the most powerful bite forces ever measured for any land animal in Earth's entire history. Despite popular imagination often picturing Tyrannosaurus rex with smooth, scaly skin, some fossil evidence suggests certain tyrannosaur relatives may have had simple feather-like coverings, and scientists continue to study exactly how much of its body may have been feathered In fact, an enormous number of dinosaurs, particularly smaller, more bird-like species, are now believed to have had feathers, a discovery that has significantly reshaped how paleontologists picture much of the dinosaur world compared to older, purely scaly depictions. Birds themselves are now understood by the overwhelming scientific consensus to be living descendants of a specific group of dinosaurs, meaning technically, dinosaurs never fully went extinct at all. They simply took to the skies and kept going. The velociraptor, made famous by films depicting it as roughly human-sized, was in reality considerably smaller, closer to the size of a large turkey, and almost certainly covered in feathers rather than bare, scaly skin. Some dinosaurs were remarkably small overall, and a few of the tiniest known species were roughly the size of a modern chicken, a stark contrast to the towering giants more commonly pictured when people imagine the dinosaur world. The Stegosaurus, known for the distinctive row of large plates running along its back, had a brain roughly the size of a walnut, and scientists remain uncertain about the plate's exact purpose, with theories ranging from temperature regulation to visual display. Triceratops, easily recognized by its large frill and 3 horns, is now understood through careful fossil study to have likely lived in herds, offering these plant-eating giants some measure of safety in numbers against prowling predators. Some dinosaur fossils have been so well preserved that scientists have been able to determine the actual color patterns of their feathers using microscopic structures preserved in the fossilized tissue to reconstruct surprisingly vivid, detailed images of how they once appeared. Dinosaur eggs, when fossilized, offer remarkable insight into prehistoric life, and some fossil sites have preserved entire nesting grounds, complete with eggs, hatchlings, and evidence of parental care that overturned earlier assumptions that dinosaurs simply abandoned their young. Certain dinosaur species are now believed to have cared for their young for an extended period after hatching, bringing food back to the nest and protecting vulnerable hatchlings. Behavior more commonly associated today with birds than with reptiles. Fossilized dinosaur footprints, preserved in ancient mud that later hardened to stone, allow scientists to estimate how fast certain species could move, and some smaller, lighter dinosaurs are believed to have been capable of considerable bursts of speed. The largest predatory dinosaur ever discovered, even larger than Tyrannosaurus rex, is believed to have spent considerable time in and around water, with certain skeletal features suggesting a lifestyle more adapted to hunting in rivers and shallow seas than pursuing prey purely on land. Pterosaurs, the flying reptiles often mistaken for dinosaurs, included some species with wingspans wider than a small airplane, making them among the largest flying animals ever known to have existed on Earth. Marine reptiles swimming in prehistoric oceans during the age of dinosaurs included massive, long-necked creatures and powerful dolphin-shaped predators. Entire ecosystems of enormous ancient life thriving beneath waves that no dinosaur ever needed to enter. The world dinosaurs lived in looked considerably different from the one we know today, and the continents were arranged in different positions entirely, still gradually drifting apart from an earlier, more unified supercontinent throughout much of the dinosaur era. The climate during much of the age of dinosaurs was significantly warmer than today's, with little to no permanent ice at the poles, supporting lush, dense vegetation across regions that are considerably colder and drier in the modern world. Flowering plants, so common and familiar today, didn't actually appear until partway through the age of dinosaurs, meaning the earliest dinosaurs lived in a world of ferns, conifers, and cycads entirely without the colorful blossoms we associate with plant life now. Dinosaurs are generally divided by scientists into two broad groups based on the structure of their hip bones. One group whose hip structure resembles that of modern reptiles, and another whose hip structure, somewhat confusingly, resembles that of modern birds. Despite that naming, birds actually evolved from the group with the reptile-like hip structure, one of several confusing quirks in dinosaur classification that trace back to how these categories were first established long before modern evolutionary relationships were fully understood. The extinction event that ended the age of dinosaurs, roughly 66 million years ago, is now widely attributed by scientists to a massive asteroid impact, striking what's now the coast of Mexico with catastrophic global consequences. That same asteroid impact is believed to have triggered enormous fires, blocked sunlight with debris thrown into the atmosphere, and dramatically cooled the global climate for an extended period, conditions severe enough to end the reign of the non-avian dinosaurs entirely. Not every living thing died out in that same extinction event, and several groups of animals, including small mammals, certain birds, and various reptiles, survived and eventually diversified into the enormous variety of life recognizable across the world today. The impact crater left behind by that same asteroid, though now largely buried and eroded, has been identified and studied by geologists, offering physical, measurable evidence supporting the broader theory of what actually ended the dinosaur age. Fossilization itself is an extraordinarily rare process, requiring very specific conditions to preserve an organism's remains long enough to gradually turn to stone, which is part of why paleontologists believe the fossil record represents only a small fraction of all the species that ever actually existed. The study of dinosaurs falls under the broader science of paleontology, and researchers in this field carefully excavate, clean, and analyze fossils using techniques that have become increasingly sophisticated, including detailed CT scanning that reveals internal bone structure without any physical damage to the fossil itself. Some dinosaur fossils have been discovered with preserved stomach contents still intact, offering direct physical evidence of exactly what specific individual animals had eaten shortly before their death millions of years ago. Coprolites, the scientific term for fossilized dinosaur droppings, may sound unusual, but they provide genuinely valuable scientific information about ancient diet and digestion, carefully studied by researchers despite their admittedly less glamorous nature. The largest dinosaur footprint ever discovered measures well over a meter across, offering a striking, tangible sense of scale for some of the truly enormous creatures that once walked across what is now solid, quiet stone. Certain dinosaur species showed clear fossil evidence of healed injuries, including broken bones that mended during the animal's lifetime, suggesting these creatures were capable of surviving and recovering from considerable physical trauma. Paleontologists have identified evidence suggesting some dinosaurs engaged in combat with members of their own species, likely over territory, mates, or social standing, based on healed injury patterns matching the specific weapons, horns, or club-like tails certain species possessed. The Ankylosaurus, a heavily armored plant-eating dinosaur, had a large bony club at the end of its tail capable of delivering considerable force, likely used defensively against attacking predators. Some dinosaurs are now understood to have lived in surprisingly cold climates, including areas within the ancient Arctic Circle. And certain species show adaptations, including possible insulating feathers suited to enduring long stretches of seasonal darkness and cold. The idea that dinosaurs were sluggish, cold-blooded creatures, once widely assumed, has been substantially revised by modern research, which suggests many dinosaur species maintained a metabolism somewhere between that of modern cold-blooded reptiles and warm-blooded mammals and birds. Growth rings preserved within fossilized dinosaur bones, similar in principle to tree rings, allow scientists to estimate how old an individual animal was when it died, and how quickly different species grew throughout their lives. Some of the largest dinosaurs grew at a remarkably fast pace during their early years, reaching enormous adult sizes within just a couple of decades, a growth rate considerably faster than most large animals alive today. The Spinosaurus, notable for the tall, sail-like structure along its back, is now believed by many researchers to have spent considerable time swimming and hunting in ancient rivers. One of the few dinosaurs thought to have been genuinely semi-aquatic. Certain small, feathered dinosaurs are now believed to have been capable of at least limited gliding or powered flight, blurring the once much clearer line scientists drew between dinosaurs and the birds that eventually descended from them. Fossil evidence of dinosaur nests found clustered closely together suggests that certain species returned to the very same nesting grounds repeatedly across multiple years, much like many modern bird species do today. The very first nearly complete dinosaur skeleton ever assembled and displayed publicly caused a sensation at the time, drawing enormous, curious crowds eager to see direct physical evidence of these ancient, almost unimaginable creatures. Dinosaur fossils have been discovered on every continent on Earth, including Antarctica, evidence that dinosaurs successfully spread across the entire globe during the many millions of years they dominated life on land. Amber, the same fossilized tree resin mentioned in an earlier episode of this series, has occasionally preserved small prehistoric insects and even feathers from the dinosaur era in extraordinary, delicate detail, trapped completely intact for tens of millions of years. Certain dinosaur species show evidence of complex social behavior beyond simple herding, including possible cooperative hunting among some predatory species based on multiple individuals found fossilized together at single kill sites. The sheer diversity of dinosaurs during their long reign was considerable, and scientists have formally identified well over 1,000 distinct species so far, with new discoveries still being made regularly across active fossil sites around the world. Certain regions of the world, thanks to particular geological conditions, have proven especially rich in dinosaur fossils, and paleontologists continue to return to these same productive sites year after year, still uncovering new specimens. The study of dinosaurs remains a genuinely active, evolving science, and major discoveries continue reshaping scientific understanding on a fairly regular basis. meaning much of what's confidently stated about dinosaurs today may itself be gently revised in the years ahead. Dinosaurs are broadly grouped by scientists into several major categories based on body shape and diet, including the long-necked plant eaters, the two-legged meat eaters, and various armored, horned, or duck-billed plant eaters. Each group adapted to a distinctly different lifestyle across the ancient landscape. The largest dinosaur known from reasonably complete remains is estimated to have weighed as much as several elephants combined, stretching well over 100 feet from head to tail, a scale so enormous that scientists continue refining their estimates as new, more complete fossils are discovered. By contrast, one of the earliest small dinosaurs ever formally described was barely larger than a house cat, a helpful early reminder to scientists that dinosaurs came in an enormous range of sizes, not just the towering giants most commonly pictured. Early dinosaur research in the 19th century was shaped considerably by an intense, occasionally bitter rivalry between two American paleontologists, each racing to discover and name as many new species as possible. A competitive period that, despite its tensions, dramatically accelerated early dinosaur science. One of the most famous early dinosaur reconstruction mistakes involved a plant-eating dinosaur, initially assembled with its distinctive thumb spike mistakenly placed on its nose. An error later corrected once more complete. Skeletons revealed the spike's actual position on the hand. Similarly, the fossil of a dinosaur once thought to have been actively stealing eggs from another species' nest was later re-examined, and scientists came to realize the animal was very likely fossilized while protecting its own eggs, not raiding someone else's. A small but meaningful correction to its reputation. Older dinosaur depictions often showed them dragging their tails along the ground in a sluggish, lizard-like posture, but modern understanding of dinosaur skeletal structure indicates most species held their tails up and out, balancing their body weight while walking or running. Certain duck-billed dinosaurs had elaborate, hollow, bony crests on their heads, and scientists believe these structures may have functioned much like a natural instrument, allowing the animal to produce distinctive, resonant calls audible across considerable distances. Studying the internal shape of fossilized skull cavities allows scientists to create detailed casts revealing the approximate shape of a dinosaur's brain, offering valuable indirect clues about which senses, like smell or vision, may have been especially well developed in a given species. Tyrannosaurus rex in particular is believed to have possessed an unusually strong sense of smell, based on the size and structure of the specific brain regions associated with detecting scent, potentially useful for locating carcasses or tracking prey across long distances. The relatively small, often mocked arms of Tyrannosaurus rex remain a subject of genuine scientific debate, with theories ranging from a role in gripping struggling prey at close range to a more limited function retained simply because they weren't costly enough to disappear entirely through evolution. Ornithomimid dinosaurs, built with long legs and a body shape resembling modern ostriches, are believed to have been among the fastest dinosaurs, likely capable of considerable bursts of speed across open ground while fleeing predators. The Mesozoic era, the broader span of time during which dinosaurs lived, is divided by scientists into three distinct periods, each lasting tens of millions of years, with dinosaur diversity and dominance gradually increasing across each successive stage. The earliest dinosaurs appeared during the first of these periods, sharing the ancient landscape with a wide variety of other reptiles, some of which were at the time still considerably larger and more dominant than the earliest relatively modest dinosaurs themselves. Throughout much of the dinosaur era, the world's land masses were still gradually drifting apart from an earlier, more unified supercontinent, a slow geological process that helped shape how different dinosaur species eventually became isolated and evolved distinctly across different continents. Alongside the asteroid impact theory, scientists have also studied evidence of massive, prolonged volcanic activity occurring around the same general time as the extinction event, and many researchers now believe a combination of both factors likely contributed to the scale of the resulting extinction. The extinction event that ended the age of dinosaurs wasn't the first mass extinction in Earth's history, and an even more severe extinction event, occurring tens of millions of years before dinosaurs even existed, wiped out a considerably larger percentage of all life on Earth at the time. Small, often nocturnal mammals coexisted alongside dinosaurs throughout most of the Mesozoic era, generally remaining modest in size, likely in part due to the sheer ecological dominance dinosaurs maintained across nearly every available land habitat. Dinosaur eggs varied considerably in size and shape between species, and some were elongated and narrow, while others were closer to round, their shells showing microscopic structural differences that paleontologists can sometimes use to help identify which type of dinosaur laid them. One particular species, whose name translates roughly to good mother lizard, was identified through fossil evidence showing clear signs of organized nesting colonies and dedicated parental care, directly challenging older assumptions that dinosaurs were largely indifferent parents. Fossilized dinosaur skin impressions, though rarer and less dramatic looking than bones, have been recovered at several sites, revealing detailed scale patterns and, in some feathered species, the delicate structure of preserved feather impressions as well. An extraordinary set of fossil beds in northeastern China has produced some of the best preserved feathered dinosaur specimens found anywhere in the world. Fine ash from ancient volcanic eruptions, preserving remarkable, delicate detail that would otherwise have been lost entirely. Archaeopteryx, an early transitional fossil discovered in the 19th century, displayed a striking mix of reptilian and bird-like features, and remains one of the most historically important fossils, supporting the now well-established link between dinosaurs and modern birds. Dinosaur classification continues to be actively debated and revised by paleontologists, and relationships between certain species are periodically reorganized as new fossils and more advanced analytical techniques become available to researchers. Many dinosaur names describe a distinctive physical feature, honor the location where the fossil was discovered, or credit the researcher responsible for its discovery, a naming tradition that continues largely unchanged into modern paleontological practice today. Several of the largest dinosaurs rivaled or even exceeded the size of a modern blue whale in overall length, though the blue whale remains considerably heavier overall. its body supported by buoyant ocean water rather than needing to bear its own weight on land. Predatory dinosaurs and their plant-eating prey appear to have engaged in a long, gradual evolutionary back and forth, with increasingly effective defensive adaptations like armor, horns, and spikes emerging alongside increasingly powerful predatory adaptations over millions of years. The Utah raptor, a considerably larger relative of the more famous and much smaller velociraptor, is now understood by scientists to be closer in size to the fictional depictions popularized decades ago, even though those depictions were technically named after its smaller cousin. Fossilized trackways, long stretches of preserved dinosaur footprints, occasionally reveal multiple individuals moving together in the same direction at the same time, offering rare, direct physical evidence supporting the idea that certain dinosaur species traveled in herds. Certain fossil sites contain what scientists call bone beds, dense concentrations of numerous dinosaur skeletons from the same species found together, possibly the result of a sudden flood, drought, or other catastrophic event affecting an entire herd at once. The very first dinosaur skeleton ever assembled and put on public display drew enormous, curious crowds eager to see direct physical proof of these barely understood ancient creatures, a level of public fascination with dinosaurs that has, in many ways, never really faded since. Scientific illustrations of dinosaurs have changed dramatically over the past century, shifting away from slow, tail-dragging, dull-colored reptiles toward more dynamic, often feathered, and considerably more active depictions reflecting our steadily improving understanding. Amateur fossil hunters and dedicated citizen scientists have contributed meaningfully to dinosaur paleontology over the years, occasionally discovering significant specimens that professional, formally trained researchers later carefully excavate and study in detail. Dinosaur fossils require careful, often painstaking preparation once removed from the ground, and skilled technicians may spend months or even years slowly and carefully removing surrounding rock to fully reveal a single delicate specimen. Certain dinosaur species show evidence of complex feeding adaptations, including specialized teeth suited to slicing meat, grinding tough plant material, or filtering food from water, each adaptation closely matched to a particular diet and lifestyle. Herbivorous dinosaurs employed a range of different strategies for processing tough plant material, and some species swallowed stones that remained in their digestive system, believed to have helped grind down fibrous vegetation, much like a natural mill. The sheer variety of environments dinosaurs successfully inhabited across the world, from lush river deltas to arid deserts, and even cold polar regions, reflects just how successfully and thoroughly this group of animals adapted to nearly every available habitat on Earth during their long reign. Paleontologists estimate that the fossils formerly discovered and named so far likely represent only a small fraction of all the dinosaur species that ever actually existed, with countless others lost entirely to time without ever leaving a trace that could fossilize at all. New dinosaur species continue to be discovered and formally described at a remarkably steady pace even today, with researchers identifying new species from freshly excavated fossils on a regular, ongoing basis nearly every year. Modern imaging and scanning technology has allowed scientists to study delicate internal fossil structures, without ever needing to physically cut into or damage an irreplaceable specimen, preserving it fully intact for future study using techniques not yet even invented. Dinosaur fossils, despite being many millions of years old, are technically not the original bone material at all in most cases, but rather a slow mineral by mineral replacement process that gradually transforms the original organic material into solid stone over an immense span of time. Certain marine reptiles swimming alongside the dinosaurs gave birth to live young rather than laying eggs, an adaptation well suited to a fully aquatic lifestyle where returning to land to nest simply wasn't practical or necessary. Pterosaurs, despite sharing the skies for an enormous stretch of time, weren't dinosaurs at all, but a separate group of flying reptiles, with their wings supported by a single, dramatically elongated finger, rather than the feathered wings birds would later develop. Some of the smallest pterosaurs were roughly the size of a modern sparrow, while some of the largest, already mentioned for their enormous wingspan, may have been capable of standing nearly as tall as a modern giraffe when their wings were folded. Dinosaur teeth were continuously replaced throughout an individual's life, much like modern crocodiles, meaning a single dinosaur might go through many complete sets of teeth over its lifetime, rather than relying on just one set the way most mammals do. Certain plant-eating dinosaurs possessed hundreds of small, closely packed teeth arranged in continuous grinding batteries, remarkably efficient at processing tough, fibrous plant material consumed in enormous daily quantities to sustain their massive body size. The largest predatory dinosaurs required an enormous amount of food to sustain their size, and scientists estimate a large carnivore like Tyrannosaurus rex may have needed several hundred pounds of meat in a single meal to meet its caloric needs. Dinosaur fossils are occasionally discovered with bite marks from other dinosaurs still visible in the bone, physical evidence of ancient predation, scavenging, or occasional violent conflict between individuals preserved directly in the fossil record. Certain herbivorous dinosaurs developed elaborate defensive adaptations beyond simple armor, including tail spikes, clubbed tails, and sharp thumb spikes, each representing a different evolutionary solution to the constant pressure of predation. The Stegosaurus's tail, lined with sharp defensive spikes, has been given an informal nickname by researchers, referencing its effectiveness as a weapon. And fossil evidence of punctured predator bones supports the idea that it was genuinely used in active defense. Dinosaur eyesight varied considerably between species, and predatory dinosaurs like Tyrannosaurus rex are believed, based on the forward positioning of their eye sockets, to have had excellent depth perception, useful for accurately judging distance while hunting. Certain long-necked dinosaurs may have used their impressive height not just for feeding on tall vegetation, but potentially for visual display purposes as well. A large, imposing presence that may have helped deter potential predators without any need for direct confrontation. Fossilized dinosaur nests are sometimes found arranged in organized, evenly spaced patterns across a single site, suggesting these locations functioned as dedicated, repeatedly used colonial nesting grounds, returned to across multiple breeding seasons. Certain dinosaur hatchlings appear, based on fossil evidence, to have been relatively helpless and dependent immediately after hatching, while others seem to have been considerably more developed and capable of moving and even feeding themselves almost right away. The rate at which different dinosaur species grew varied considerably, and some smaller species reached full adult size within just a few years, while some of the largest giants may have continued growing gradually for several decades before finally reaching their maximum size. Certain dinosaur bones show clear evidence of specific diseases and health conditions, including signs of arthritis and bone infections, offering paleontologists a surprisingly detailed, sometimes poignant window into the physical hardships individual animals experienced during their lives. Fossil evidence suggests some dinosaur species were capable of surviving with significant permanent injuries, including partially healed broken bones, indicating both a herd's occasional tolerance for weaker or injured members and considerable individual resilience. Dinosaur bones, particularly among the larger species, were often partially hollow, a lightweight structural adaptation similar to those found in modern birds, helping to reduce overall body weight without significantly compromising structural strength. Certain predatory dinosaurs hunted primarily alone based on typical fossil discovery patterns, while others, based on the previously mentioned evidence of multiple individuals found together at kill sites, may have at least occasionally hunted cooperatively in small groups. The specific pigments preserved in certain exceptionally well-preserved fossil feathers have allowed scientists to determine that some small feathered dinosaurs displayed strikingly bold color patterns, including combinations of black, white, and reddish-brown banding. Dinosaur fossils found in regions that were, during the Mesozoic era, positioned much closer to the ancient poles than they are today, offer valuable evidence about how certain species adapted to living through extended periods of seasonal cold and darkness each year. Certain small dinosaur species discovered in these ancient polar regions show enlarged eye sockets, a likely adaptation for improved night vision, useful for remaining active and successfully hunting during long stretches of low winter light. The concept of a single, unified dinosaur extinction moment is, in reality, a simplification, since the extinction event's effects likely unfolded over a period of months or years following the initial impact, as environmental conditions gradually deteriorated worldwide. Some scientists have studied the specific layer of sediment found at sites around the world, dating to the exact time of the extinction event. A thin, distinctive layer enriched with a rare element strongly associated with asteroid impacts, offering global physical evidence of the same catastrophic event following the extinction of the non-avian dinosaurs. Surviving mammals diversified remarkably quickly in evolutionary terms, gradually expanding into the many ecological roles left newly available across a dramatically changed world. The rich variety of dinosaur species discovered so far continues to surprise even experienced paleontologists. In entirely new categories of dinosaur, unlike anything previously known, are still occasionally identified from freshly excavated fossil remains. Museum exhibits displaying dinosaur skeletons today are typically composed of a careful combination of real fossilized bone and lightweight replica casts, since complete, fully original skeletons are exceptionally rare and often too fragile for standard active public display. The study of ancient plant life alongside dinosaur fossils, sometimes called paleobotany, helps scientists reconstruct the specific ecosystems dinosaurs actually lived within, offering essential context well beyond the animals themselves. Fossilized ancient pollen and plant spores, though microscopic, are remarkably well preserved in many sediment layers, allowing scientists to determine with considerable precision exactly which plant species grew alongside particular dinosaur communities. Certain dinosaur fossil sites have yielded so many well-preserved specimens that they've become internationally significant research locations, drawing paleontologists from around the world to study and compare specimens found there over many decades of careful, ongoing excavation. And so tonight, we leave the age of dinosaurs exactly where the fossil record so often does, in stone and quiet layers of ancient earth, waiting patiently for someone curious enough to dig. Certain ancient rock formations, layered gradually over enormous stretches of time, preserve a visible, physical record of the exact moment the dinosaur age ended. A thin boundary layer separating rock containing dinosaur fossils below from rock entirely, without them above. Radiometric dating techniques, measuring the slow, steady decay of naturally occurring radioactive elements within volcanic rock layers near dinosaur fossils, allow scientists to determine remarkably precise ages for specimens that are otherwise many tens of millions of years old. The very first scientifically documented dinosaur bone, though not immediately recognized for what it truly was actually described in print centuries before the word dinosaur had even been coined, initially mistaken for the remains of a giant human or a large unfamiliar animal. Certain dinosaur species developed elaborate head crests, frills, or horns that scientists believe may have served largely for visual display and species recognition, helping individuals identify members of their own species at a glance across a landscape shared with many other similar creatures. The Parasaurolophus, known for its long backward curving crest, is believed by some researchers to have been able to produce a deep, resonant call by pushing air through the hollow internal passages running through the crest itself, a built-in natural instrument unique to this particular dinosaur. Certain smaller predatory dinosaurs are now believed, based on limb proportions and fossil evidence, to have been remarkably agile, capable of quick, precise movements suited to hunting smaller, faster prey through dense vegetation. Dinosaur fossils are occasionally found in association with fossilized plant material, still preserved in remarkable anatomical position, offering rare direct evidence connecting specific plant-eating species to the exact vegetation available in their immediate environment. The overall dominance dinosaurs maintained across ecosystems worldwide for such an enormous stretch of time is considered remarkable even by paleontological standards, especially considering how many other groups of animals rose and fell entirely during that same extended period. Certain long-necked dinosaurs are now believed, based on detailed study of their neck vertebrae, to have held their necks in a more horizontal, forward-reaching posture than the dramatically upright pose often shown in older, classic illustrations. Dinosaur research increasingly relies on collaboration between international teams of scientists, sharing data, fossil casts, and imaging technology across borders, accelerating the overall pace of new discoveries considerably compared to earlier, more isolated eras of research. Certain fossilized dinosaur trackways preserve evidence of an animal briefly changing pace, shifting from walking to a faster run, frozen permanently within the ancient mud that has, since that ordinary moment, quietly turned entirely to stone. The overall body plan shared by many two-legged predatory dinosaurs, balanced carefully by a long counterweighted tail, represents a remarkably efficient evolutionary solution, one echoed independently in several unrelated dinosaur lineages that arrived at very similar proportions. Fossilized dinosaur remains discovered in avalanche or flood deposits occasionally preserve entire herds together in a single dramatic moment, offering scientists an unusually complete, if tragic, snapshot of ancient group behavior. The ongoing rate of new dinosaur discoveries suggests strongly that our current understanding, however detailed, still represents an incomplete picture, with entire species, behaviors, and evolutionary relationships very likely still waiting patiently to be uncovered. Certain small mammal fossils found alongside dinosaur remains show evidence of specialized adaptations, including some capable of climbing or gliding, hinting at a far more varied and adaptable ancient mammal community than older assumptions once suggested. The disappearance of the non-avian dinosaurs ultimately opened enormous ecological opportunity for the mammals that survived, gradually setting the stage across many millions of subsequent years for the eventual rise of the very different world you know today. And somewhere, deep beneath layers of ordinary soil and stone all around the world, the quiet, patient remains of that ancient age are still resting exactly where they've rested for tens of millions of years, needing nothing from anyone awake to keep waiting. The same ancient ground that once trembled beneath enormous footsteps is, right now, simply resting quietly beneath you, layer upon layer of stone, holding memories older than anything else you've heard about tonight. Somewhere, a fossil is still waiting, undisturbed in the dark earth, and none of it needs anything from you right now except your rest. You've drifted tonight through ferns and volcanoes, through giants and feathers and footprints pressed into ancient mud, past an entire world that came and went long before anything human ever existed to watch it. The whole vast, patient story of the age of dinosaurs, resting now beneath layer upon layer of quiet stone. Let it hold you now, the way it's always held everything else. Let your breathing settle into its own slow rhythm. There's nowhere else you need to be, nothing else you need to understand tonight. Just this quiet ancient world and this quiet rest, drifting gently together in the dark. Sleep well, and I'll see you next time for another 100 facts, drifting softly into sleep.